Hey, Math 8. I'm going to go over the homework number 9 here, the Chapter 6 review. I will slide through the answers first so you can grade your paper, see all the answers, and then I will explain each problem, and you can just slide through the video and get explanations on the problems that you have questions about. And we'll be taking a test on this next week. So come in the morning during reading perhaps next week and get your questions in if you have more questions, or email me with questions before we take the test. So here we go. Let me slide through the answers. You can see the answers to 1 and 2 there, where you had to graph the table and then tell whether it's linear or not. And there's the answer number 3. And there we go. Number 4 and 5 and 6 and 7, 8, and 9. And number 10, you should have the exact same table I do and the exact same graph. And for 11 and 12, you should have the exact same table and the exact same graph. And again, for 13, you should have the same table and the same graph. And 14 and 15 and 16, those can be tricky. And 17 and 18. 19 and 20, 21 and 22, 23 and 24, and finally the 2 tile patterns, 25 and 26, all right? So I'm going to go through them one by one. And I will go through them in blue. All right, so on these first problems, my job is to graph the table. Remember, when you graph an ordered pair, the x value tells you how far to go left or right. The y value tells you how far to go up or down. I always start at the middle of the graph. So this would be left 5, right? Negative, positive. Up is positive, down is negative. I'd go left 5, down 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4 puts me there. Then I'd go left 2, down 1, and that puts me there. Then I'd go left 0, up 1, which puts me here. Then I would go right 1, up 2, which puts me here. And right 5, up 6, puts me there. And it looks like those points all line up in a straight line, therefore it is linear. Number 2, for number 2, I would go left 2, down 4. So starting at the center, left 2, down 4 puts me there. I would go left 1, down 1, there. I would go left 0, up 0. That leaves me right in the middle. Right 1, up 1, there. Right 2, up 4, here. Those do not line up in a straight line, obviously. They curve. So that one is nonlinear. So number 3, I ask you to tell me, when you look at a table of ordered pairs, how can you tell if it is linear or not? It is linear if the y values increase by the same amount each time. Now that is fairly easy in a table like number 2, where the x's go in order by 1s. It is not as easy in a question like number 1, where they do not go by 1s. You have to figure that out. We're going to do that in a little bit, so we'll save that. Number 4, How can you tell if an equation is linear or not? Well, it is linear if the variables do not have any exponents and are not multiplied together. Then it would be linear. All right, so this would be like question number 3. Now we're actually going to use the skills from question number 3 that hopefully you know. We're going to see, do these tables go up? Do the y values increase by the same amount? So from here to here, that went up 1.2, right? I could figure that out by subtracting if I had to. Negative 0.6 minus negative 1.8 is how I got the 1.2. And then from negative 0.6 to 0.6 is also 1.2. And this is also 1.2, and this is also 1.2. So because it's going up by the same amount each time, it's linear. Whereas this one, from 8 to negative 4, that is going down by 12. From negative 4 to negative 18, that is going down by 14. So because it went down by different amounts, it is not increasing by the same amount each time. It's different amounts. That's what makes it nonlinear. And in this one, notice that the x's go by 2's every time. But since the x's go by the same amount every time, that means the y's need to go by the same amount every time. So from negative 7 to negative 3, that is going up 4. From negative 3 to 1, up 4. 1 to 5 is up 4, and 5 to 9 is up 4. It does go by the same amount every time, which is why it's linear. Number 6. So the secret to this is that it must have a constant increase. The y's must go by the same amount each time. So the first thing I'm going to figure out is, how much do the y's go up by each time? And I'm going to use this and this. Notice that the y's went up 12 when the x went up 3. So if the y's are going up 12 when the x's go up 3, how much do the y's go up when the x's go up 1? And you can get that by dividing, right? You always divide the amount the y's went up divided by the amount the x's went up. And that turns out to be 4. The y's are going up by 4 each time. So for this one, I need to add 4. Oops. Negative 2 plus 4 is how I got the 2. And then we add 4, and that seems to work, 6. And we added 4 and got 10. And we added 4 and got 14, and so on, right? All right. So this is like determining whether you know how to look at an equation and tell if it's linear or not. Remember, no exponents on the variables, and the variables cannot be multiplied together. Not allowed to have that. So number 7, there are no exponents and the variables are not multiplied together. It's linear. Number 8 has no exponents. The variables are not multiplied together. It's linear. But number 9 has exponents on the variables. So that's why it is nonlinear. Number 10. Okay. So it tells me in the directions that if the equation is linear, I am supposed to use these 3 x values. So the first thing I noticed is this equation, number 10, does not have any exponents, and the variables are not multiplied together. So it is linear. So the first thing I do is I choose my x values, 1, 2, and 3. Then I need to figure out the y values that go with them. So to figure out the y values, I take each x value and I substitute it into the equation. So it would look like that. And I would put 2 in for x. And I'm not sure I'll do 3. So this one, 10 times 1 is 10 minus 5y equals 15. I am trying to figure out what y value I get when I put 1 in for x. So I'm going to do that by solving for y. I'm going to subtract 10 from both sides, trying to get the y by itself. And it gives me 5. And then I'm going to divide by negative 5 on both sides to cancel that out. And I get y equals negative 1. So when I put 1 in for x, I get negative 1 for the y value. And then I move on to the 2. And I do 10 times 2. Well, that would be 20 minus 5y equals 15. Now I'm trying to get the y by itself again. So I would subtract 20 from both sides. All right, we call this solving for y. And then I would divide both sides by negative 5. And I get y equals 1. And if I did it for the 3, if I put 3 in for x, I would get 3 for y. I don't feel like I need to do it again for you. And so then I graph these points. And when I graph them, remember, this tells me to go right 1, down 1. So I went right 1, down 1, and got there. Then I went right 2, up 1, and got there. Then I went right 3 and up 3, and ended up there. And I connected them with the red line. Number 11. This one is also linear because it has no exponents. And so I'm going to use my x values. All right, I'm going to substitute the x values in for x. So this would be 1/2 times 1 minus 4. And it would be 1/2 times 2 minus 4. And I would do the same thing for 3, but I don't feel like I need to show you all 3 of them. So this one is easy to solve for y. You just need to do the arithmetic. 1/2 times 1 is 1/2. And then 1/2 minus 4 is negative 3.5. So when x equals 1, the y value you get is negative 3.5. And then I put 2 in for x. And I do the arithmetic. 1/2 times 2 is 1. And then 1 minus 4 is negative 3. So when I put 2 in for x, y was negative 3. And I could do 3, and if you need me to do it, email me or come in and ask me. If I put 3 in for x, I would end up with negative 2.5. So to graph the decimals, I have to estimate where 0.5 is. 0.5 is halfway down a block or up a block. So this first one, I'm going to go 1 to the right, and I'm going to go down 3.5 blocks. And that takes me to here. And then I'm going to go 2 to the right and go down 3 blocks. So that takes me to here. And then I'm going to go 3 to the right and go down 2.5 blocks, which takes me to here. And then I connected them with the red line. All right, number 12. This is a nonlinear equation because it has an exponent. So, because it's nonlinear, the directions told me my x values needed to be negative 2, negative 1, 0, 1, and 2. And to find the y values, I substitute those in for x one at a time. So the first one would be y equals negative 2 times negative 2 squared plus 4. Let's go ahead and do that one. So one way you could do is you could just type this into your calculator exactly as it looks. Keep the parentheses, keep the exponent, type the whole thing in. It will give you the correct answer. But since we are awesome Math 8 students, we are going to solve this first by hand. So the first thing I would do is the exponent here. I would do -2 to the second power. And -2 to the second power is +4. So here I get +4. And then I would multiply -2 times 4. That is -8. And finally, I would add -8 plus 4, and I would get -4. So when I put -2 in for x, I get -4 for y. Let's put that in the table. And I'll do one more. I'll do -1. So -1 would look like this when I put it in for x. And first I would square the -1. That means -1 times -1, which is +1. Then I would multiply the -2 times the +1, and that's -2. And finally I would add the -2 plus the 4, and that would be +2. So when I put -1 in for x, I get a +2 for y. And I would repeat this process with each of the last 3 numbers. And so when I go to graph these, all right, remember the x goes left or right, and the y goes up or down. I'm going to go left 2, down 4. Starting at the center, I go left 2, down 4, and it puts me there. Then I go left 1, up 2, puts me there. Then I go left 0, up 4, puts me right on the line there. Right 1, up 2, puts me there. And right 2, down 4, puts me there. And I connect those with a better, red one's not very good, a better smooth curve. I guess it's okay. All right, number 13. I think this is the hardest one because the y values are terrible. But the process is the same as it has been for the other 3. First, I recognize that this is linear because it has no exponents and the x and y are not multiplied together. So because it's linear, I pick the x values 1, 2, and 3. And then I substitute each one of those in for x. So I'm going to start with the 1, and I'm going to substitute it in for x. And then I want to solve for y, right? I want to find what y value I get when x is 1. So first I would multiply 5 times 1. That would be, oops, forgot the negative, that. Now I'm solving for y, so I need to get the y by itself. I would start by subtracting 5 from both sides. That gives me 8y equals -17. Then I would divide both sides by 8. And if I divide 17 by 8, -17 by 8, I get -2.125. I would actually be okay if you rounded that to the nearest 1 decimal place. Or if you want to keep all 3 decimals, you can. Next up, I put 2 in for x. So instead of 5 times x, it would be 5 times 2 plus 8y equals -12. And I would multiply the 5 and the 2 together and get 10 plus 8y equals -12. Now I'm trying to solve for y. So I would subtract 10 from both sides, giving me 8y equals -22. And I would divide by 8, and -22 divided by 8 is -2.75. Again, you can keep the whole thing, or you can round to 1 decimal place, because on the graph, you're not really able to tell more than 1 decimal place at all. All right, so that brings me to the third one, and I'm not going to do the third one. You would do it exactly the same way. You would put 3 in for x, and you would get this decimal. So to graph those, this first one, I go 1 to the right, and I go down 2.1. So that is just barely more than 2 boxes. And you can see I went 1 to the right. I went down just barely more than 2, right? And then in the next one, I go right 2, and I go down 2.75. So that would be more than 2.5, right? 2.5 would be 2.5. So I'm going down more than 2.5 boxes, and I'm just estimating 1, 2, and I went down more than 2.5. And then the last one, I'm going right 3, and I'm going down 3.3. So that would be more than 3, but not more than 3.5. So I went down a little less than 3.5 boxes, and I connected those guys with the line. All right, tough one, right? All right, so now we are finding the unit rate. So the unit rate is just the amount each time, right? It's how much the y goes up each time. So in a table, I would figure out how much the y is going up, but in this case, it's going up 1185 for each x, and the x's went up by 15. So 1185 for 15 x's would be how much for each x? And you always get this by dividing. 1185 divided by 15. When you get that, when you divide that, you get 0.79. You just need to make sure you put the units on it. And the units is always the y units, dollars, per, right? You can either write the word per or use the slash. The x units, ounces. So this is dollars per ounce. Number 15. So I think the graph is hard. On the graph, you want to make sure you use points that I have obviously made. So again, I need to figure out how much y is going up each x. So one thing I can do is I can make a little table, and I can pick a couple ordered pairs. Now this is a nice one, 0, 0, so I might as well choose that one. And this graph is actually exceptionally easy because 1 is also on here. X equals 1, and y equals, we'd have to figure it out, that would be 15, right in the middle of 10 and 20. So it's quite obvious for this one, when x goes up 1, y goes up 15. So it's going up 15 each time. And I need to put the units on it. Remember, it's always the y units, which is dollars, per x units, which is pounds. So $15 per pound. Now, number 16 is a little tougher because I really only gave you a couple of ordered pairs, right? You can't really tell where the 1 is here. It's in between and you'd be guessing. We don't want to guess. We want to use exact values. So again, I'm going to make a little table, and I'm going to put 0, 0 in my table, and I'm going to put this other point here, which is x equals 4, y equals 30. And so in this one, it looks like when x goes up 4, y goes up 30. So if y is going up 30 for 4 x's, how much does y go up each x? And I get that by dividing, right? I always divide 30, the y, by the x. 30 divided by 4 is 7.5. So the y is going up 7.5 for each x. And I need to put the units on there, right? I always do the y units, which are minutes, right? This is the y-axis. This would be minutes per, you can do a slash or write the word per, minutes per the x units, which is miles. Minutes per mile. 7.5 minutes per mile would be the unit rate. Number 17. All right, so these ones that just give you one amount for each, you just divide it. And it tells me laps per minute. So I am dividing laps by minutes. And you can see I did, well, you can't see I did. So I take the 20 laps and I divide it by the 30 minutes. And that is how I got 0.6 repeating, or as a fraction, that would be 2/3. And kind of the same thing over here. I want dollars per, so I'm going to be dividing dollars by pounds. And when I do that, I would divide 235 by 3/4. And I can do that in my calculator, and it's a repeating decimal. So I rounded it to the nearest penny and made it $3.13 per pound. All right, this brings me to the situations where we need to be able to write an equation. So when I write an equation, right, the important things are, what's the beginning amount and what's the amount of increase each time? So it tells me in number 19 that the temperature at 12 o'clock was 84 degrees. That is my beginning amount. So I'm starting with y equals the beginning amount. And then it tells me that it dropped by 7 degrees each time. So that's why it's minus 7x. All right, it starts at 84 and it goes down 7 for each x. Now you have to tell what the x and the y stand for. So remember how we talked about this in class. Whatever this number represents is what the y stands for. 84 represents the temperature, right? It represents the temperature, the beginning temperature, right? Y is always the beginning amount of what? The y is the what? The beginning amount of what? And in this case, it's the beginning amount of the temperature. Whereas the x is always how often the y increases. And in this case, it's each hour. Oops. So starting at 12 o'clock, the x would be the number of hours it's been. That's how often the temperature increases. The x is how often the y is increasing. All right, number 20. Number 20, the beginning amount. Let's go back to blue. The beginning amount is she had 24 cupcakes to start. So that's my beginning amount. And it looks like she is making 36 more. So it's going up by 36 each time. Again, I don't know if I'm going to say this every time. Mercy. The beginning amount is the y value. Let's see. It's the beginning amount of what? Well, it's the beginning amount of cupcakes. Y is the number of cupcakes. Oh, no. I'm running out of space. And x is the number of hours. It's how often the cupcakes are going, the number of cupcakes are going up. X is always how often. Hopefully I don't run out of video here. Number 21, the beginning amount of tickets sold. Well, the beginning amount of tickets sold was 1,200. Before they even started selling them at the beginning, they already gave away or pre-sold 1,200 to like family and friends. And then they went on sale and they sold 6,000. So the amount of tickets is going up by 6,000 each x. So again, x is how often it's going up. How often it's going up is minutes. where the y is, what is it that's going up? It's this number. What does this number represent? It's the beginning amount of what? And it's the beginning amount of tickets sold, right? Y is always the beginning amount of whatever you're doing. And number 22. In number 22, the beginning amount is $550. And it looks like it's going down by $75 each time. So that's your equation. And then what does the x? X is how often it goes down. It goes down each month. So the number of months would be the x. And y is what this stands for. 550 what? What does 550 represent? It represents the cost of the sneakers, right? The beginning cost. All right, and that takes us to these last ones. Hopefully I'm going to get done here. Mercy. All right, so I need to figure out, to write an equation, again, I need to figure out the beginning amount. The beginning amount is y when x equals 0, and I need to figure out the amount of increase each time. So that is always how much y goes up divided by how much x goes up. So let's see. The y is going up 4 when the x goes up 1. So it's going up 4 each time. And that's why I have a 4 here, is how much it's going up each time. Okay, I'm on number 23. And I think I finished no, I didn't. So on number 23, trying to pick up where I left off because I had to edit this video. We'll see. I am trying to figure out the beginning amount. I've already figured out that the table goes up by 4 each time. Let's see here, there we go. So I need to figure out the beginning amount. And to figure out the beginning amount, I need to know what y is when x is 0. So I actually work my way backwards. And instead of going up 4 each time, I'm going to go down 4. And if I start at -1 and go down 4, I would be at -5, which is why the beginning amount is -5. We go to number 24. And in number 24, it looks like the first thing I'm going to figure out, again, is the amount of increase. So it looks like the y goes up 9 when the x goes up 3. So if the y is going up 9 for every 3 x's, how much does it go up for 1 x? And I get that, of course, by dividing. 9 divided by 3 is 3. The y is going up 3 for each x. And so that's why I have a 3 here in my equation. Then I need to figure out the beginning amount. Now the beginning amount would be what y is when x is 0. So I see here that when x is 1, y is 10. And I can work my way backwards to 0 because I know that the y goes up 3 each time. So this must be a 7, so that when the y goes up 3, when x goes up 1, I get 10, right? So this is the beginning amount, which is why I have a 7 here. All right, this takes me to the last problems, and these are really exactly what we just did. It's exactly the same as doing these tables. The only difference is first you have to make a table. So I have these tile patterns, and the x value is the figure number. So I put all the figure numbers in for x, figure 1, figure 2, and figure 3. Where the y value is the number of tiles in that figure. So this first one had 1, 2, 3, 4, 5 tiles, which is why I put 5 in. The second figure had 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. I put 9 in. The third one had 13 tiles. And now this is no different than you were doing before in the last question, 24 and 23. First, you need to figure out how much is the y going up each time. Well, it's going up by 4 each time. So my equation is going to have a 4 here, right? And then I need to figure out the beginning amount. And the beginning amount would be how many tiles are in figure 0. It'd be when x equals 0. And so if I go backwards, instead of adding 4 each time when I go to the right, I would be subtracting 4. There would be 1 tile, which is why 1 is my number there. And then the same thing for 26. First, I put the figure numbers in for x, 1, 2, and 3. Then I put the number of tiles in each figure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 tiles. And then in figure 2, there are 7 tiles and 4. And first I figured out how much is the y going up each time. Well, it's going up by negative. It's actually going down 3, right? So that is why I have a negative 3 here, because it's going down 3. And I need to figure out what y would be if x were 0. So I work my way backwards. And if I work my way backwards, I would need to increase the y's by 3. And 13 would be my beginning amount. All right, I hope that helps, and I hope I can get this edited on to the end of the other video. We'll see. Good luck.